Hello, welcome everyone, welcome back to my channel. Today I am back again with a new topic, which is Surds. Well, before that I'm running GCSE's classes, crash course classes, or if you're looking for the new session, if you're right now in year 10 and you're looking for year 11 preparation for the main GCSEs, the classes are at just £6 per hour. And also if you're looking for any subject from any, like for basically any year from year 1 to A levels, just drop us an email at exactacademy@gmail.com and we'll coordinate from there. And if you're looking for the free worksheets and free material that are available at our website, which is www.exactacademy.com. So let me start with this question number 1. It says simplify root 30 minus root 320 over root 5 times root 2. Okay, and also these 10 questions are very important. Just like I have already completed questions on the previous topics, definitely even if you're not good at these topics, even if you don't know the topics, these questions will definitely help you in acing it, obviously, and you'll be able to do questions in the main exam. But all you need to do is just go through this video, then you have to practice 2-3 times these questions. Okay, I'm not asking you to practice the other questions, take the book and solve 100 of the questions, since we are running out of time. So for that, if you are just focusing on this only, I would suggest you to practice these questions like 2-3 times, all the questions, and definitely you'll be able to solve it in the main exam. Okay, continuing this. Root 30, this is called simplifying. If you're not aware of simplifying Surds, let me tell you, simplifying Surds, that means you just have to find the prime factors. There are 2 ways, to be honest, of solving it, and you can opt any one. First is you just have to prime factorize, and I'm showing you for root 30 that what both methods are. So if I prime factorize, it will give me root of 5 times 3 times 2. On prime factorization, I get to know that root 30 is 5 times 3 times 2, and there's no repetition here. So you can't simplify root 30. It will be as it is. You can't do anything in that case. Moving on to root 30, root 320. Root 320 can be written as 2 times 2 times 2 times 2 times 2 times 2 times 5. This is how you'll factorize it. Now, this is the first method, which is prime factorization. You have to find the pairs. Finding the pairs, that means one pair, I'll write 2 as it is out there. Then again one pair, write 2 times, because root 2 times root 2 is just 2. That's why the pair of root 2 will give you 2. Similarly, root 2 will give you 2. The next root 2 will give you 2. And 5 is alone, so it will remain inside the root sign. So you'll get 8 root 5. So when you simplify root 320, you will get 8 root 5. Here, you're not able to find any pairs. So that's why it was difficult to simplify it. This is the first method by prime factorization. Let me move on to the next one. So next one was, it's root 320, and you have to find number. If you are splitting it into the numbers, it has to be a square number. If you are like easy to figure it out, that what would be that square number which I can divide 320 with. So if I look into it, I can clearly see it's 16. 16 is that perfect square number. That means when I take the root of 16, I'll get 4. Not a decimal. That's called perfect square. So 16, and this can be written as 2 times 2 times 5. So that means again I can write 16 times 4 times 5. Okay, so simply without prime factorization, I was able to split it into the perfect square numbers. So we know root 16 times root 4 times root 5. Root 16 is 4, root 4 is 2, and root 5 is as it is. It will give you 8 root 5. This method is when you have solved few questions, then it's very easy to find that number. And if you're very new to it, you're not aware of this, I would suggest you to go for the prime factorization method. You know factor tree. Just find all the factors and then find the pairs and you'll get the answer. So 320 can be written as 8 root 5. So Root 30 was root 30. This is 8 root 5. This is root 5 times root 2. From here clearly I can cancel out root 5 and root 5. And root 30 can be split into 5 times 3 times 2. So this means root 5 times root 3. See, if multiplications are under the same common surd, that means you can separate them as well. But that doesn't go with the sum if I say a plus b. So if you write root a plus root b, it won't work. So never do that. It goes with the multiplication and division only. So root 5 times 3 times 2 can be written as root 5 times root 3 times root 2 over root 2. Cancel it out. Remaining is just root 15, and that's your answer. That's how you'll get the simplified answer. Moving on to the question number B, part B. Show that 6 over root 3 can be written in the form of a root b, where a and b are integers. So part A, the question 1 part A was about the simplification of the surds, and I have already explained you how we can simplify it. The part B shows the rationalization, how we can rationalize it. Rationalization, that means if a surd number is in denominator, it's not generally an acceptable format. We have to remove that surd form. Now there are two ways of rationalizing it. One, in denominator, when you have the addition or the subtraction of two surds number, one surd and a one number. Or the second way is when you have only a surd number in the denominator, like this one. Obviously the second one I'll be explaining in the later part. This one is only about factorization of a single surd number in the denominator. So this one is 6 over root 3. I can rationalize, that means how I can remove the surd number from denominator if I'll multiply it with the same number. If I'll multiply root 3 with the root 3. You have to keep one thing in mind, surd, that means you have square rooted it. If you multiply the square root, same number, it will be 3 times 3, which is root 9, and root 9 is 3, and that's why when you multiply two surds number, it will give you that answer, that number. So if I'll multiply the denominator with the root 3 itself, I'll be able to remove it. But maths, it's not about just randomly adding and multiplying anything from your side. It has to be balanced. If you are multiplying root 3, you have to divide it by root 3 as well. Okay, or I can say if I'm dividing it by multiplying by root 3, I have to divide it by root 3. So it goes like both ways. So this will give you 6 times root 3 will give you 6 root 3, and root 3 times root 3 will give you 3, which then can be simplified to 2 root 3. So yeah, it says show that it can be written in the form of a root b. We have written, whereas a is 2 and b is 3. So it is written in the form of 2 root 3. Part C says 4 root 10 times 2 root 5 times root 20 times root 2. So it's simply, you just have to multiply them all together and simplify. So root 10 can be written as root 10, but still try to split them into its prime factors, which is 5 times 2, so that it will be written as root 2 times root 5 times 2 root 5 times root 20. If you simplify, will give you root 4 times 5, which is 2 root 5, 2 root 5 times root 2. Now clearly this root 2 and this root 2 when multiplied will give me just 2. 4 is already there, multiplied by 4. This root 5 times this root 5 will give you 5. This 2 times this 2 will give you 4 and a root 5 as it is, because there's nothing else written there. This can be written as 16 times 2, 32, and times 5, which will give you 160. So 160 root 5 is the final answer. Moving on to the part D. Estimate the value of root 130 minus root 230 over root 40 minus 4 over root 5. If it's written as estimate the value, which means you just need to put that in calculator. Obviously, even in calculator paper, if they have mentioned that simplify it, so don't write down the answers from your calculator, though you will hardly find that question. I mean, generally these type of questions are found in non-calculator paper, but even in calculator, if they are asking you to simplify it, rationalize it, they are not expecting you to put the values in the calculator and give it the answer. But if they say estimate the value of, finding the value of, that means you just have to put the values in the calculator and see what's the answer. So root 130 is 11.4 minus root 230 will be 15.16 over root 40 is 6.32 minus 4 over root 5 will be 2.23. On further putting that, you'll get the answer as this is minus 2.388. That's your answer. Or you can simplify it further, or like up to 2 decimal place if you want to give your answer. So you can say it's 2.39. Question 2 says 3 root 180 minus root 605 over 2 root 5 simplified to an integer. So if we go by the same prime factor method, we can find that this will be 3 times 6 times 2 times 5, and 6 further can be written as 3 times 2 minus root 605. So obviously you can see it can be divided by 5. So 5, and then you'll get 121, which can be written as 11 times 11 over 2 root 5. I can take out pair 3 and this 2. So this will give you answer as 3 times 2 6, and 3 is already outside, root 5 minus 11 root 5 over 2 root 5. This is 18 root 5 minus 11 root 5 over 2 root 5, which will give you answer as 7 root 5 over 2 root 5, and this is 7 over 2. Moving on to the next question. Rationalize the following. 3 over root 2 plus 1. This I was talking about. When you don't have any just surd number in denominator, if there is sum of two surd numbers, or sum of one surd number and a number, or if there is a subtraction, in that case the multiplication would be a little different. You don't have to do 3 over root 2 plus 1 and dividing and multiplying with the same number. Why? Because even if you do that, root 2 plus 1 times root 2 plus 1 will give you 2 plus 1 plus 2 root 2. Still you will be having a root number in the denominator, so we have to divide and multiply with that number that can change this one into a integer value, or where I can remove the surd number. In that case I can divide and multiply it by root 2 minus 1. So when I do this, this will give me 3 times root 2 minus 1 over root 2 plus 1 times root 2 minus 1. So that will give me 3 root 2 minus 3 over root 2 plus 1 times root 2 minus 1. When I just expand this, like multiplying this and this, so I'll get the answer as 2 minus 1. So final answer is 3 root 2 minus 3. So always remember, whatever be the sign here, you have to do the opposite. Say for example, initially it was a negative sign, so I'll divide and multiply with plus sign. That means the numbers or the surd numbers will remain exactly the same, and it will be the same if both the numbers are surd numbers, which means it's root 2 plus root 3. In that case too, you'll keep the surd number same, but you have to change the sign and you'll be able to remove the surd number from the denominator. Now I says 3 minus root 2 over root 2 plus 1. So again I'll be dividing and multiplying with the same but with the opposite sign. So this will give you 3 minus root 2 times root 2 minus 1 over root 2 plus 1 times root 2 minus 1. So 3 times root 2 will give me 3 root 2. Then 3 times minus 1 is minus 3. Minus 2 times root 2 is minus 2. And minus 2 times minus 1 is plus root 2. And over 2 minus 1. There is a simple which I already discussed. If it's a plus b times a minus b, two numbers same, but when multiplied have the different signs, can be written as a squared minus b squared. So same I am directly applying it here. Now this can be written as 3 root 2 plus root 2, that is 4 root 2, and minus 3 minus 2 is minus 5, and that's the final answer. Now moving on to the next one, expand and simplify. You just need to expand this and simplify. So same thing that we did. So expanding, that means 4 times 2, first multiplied first element of the first bracket multiplied by first element of second bracket, 8. Now multiplying the same with the second one, which is minus 8 root 3. Then multiplying root 3 by 2, you will get 2 root 3. And then multiplying root 3 times 2 root 3 is minus 2 times 3, which is 6. This one 2 minus 6 root 3, and that's your final answer. Moving on to the next one, it says root a squared plus 30 squared is equals to 10 root 34. This is whole root actually, this one. And if a is equals to p root 2, then we have to find the value of p. For that, I have to square both the sides. When I'll square the both sides, like for the first one, for this one, I'm squaring both the sides. On squaring both the sides, I'll get a squared plus 30 squared is equals to 10 root 34 whole squared. This can be written as a squared plus 900 is equals to 100 times 34. A squared is equals to 3400 minus 900, which will give you 2400. So A will give you plus minus 50. Now we have to find the value of P. So you'll get, when you put A as 50, this is P root 2. So I'll divide it by root 2, will give me 50 root 2. That's P1. Because we have two different values of A, so that's why we'll be getting two different values of P. So in that case, we'll get minus 50 over root 2 as P2. So these are two values of P that we'll get. See the question number 4. Minus root 2 and in brackets root 8 plus root 32 is equals to a root 5, and then find the value of a in its simplest form. So multiplying root 2 times minus root 2, actually it should be positive. So positive root 2 times root 8 will give you 16, root 16. And root 32 times root 2 will give you root 64 is equals to a root 5. This can be written as 4, and this is positive. 4 plus, this is 8 is equals to 8 root 5. This is 12 is equals to a root 5, and a is equals to 12 over root 5, which then can be rationalized at root 5 over root 5, which will give you 12 root 5 over 5. And that's your answer. If root 2 whole to the power of 2 over 3 is equals to a to the power of n, and 2 root 2 p plus n is equals to 4, then find the value of p, and given a is an integer. See, the first thing is, it's mentioned that a is an integer. So what I'm doing, 2 can be written as 1 over 2. Root 2, that means it's a half power. Root 2 means 2 to the power of half. Root 3 means 2 to the power of 1 over 3, cube root. Cube root, fourth root of 2 is called, this is 3, sorry. Fourth root of 2 is 2 to the power of 1 over 4. And so on. So that 2 is, root 2 is actually 2 to the power of half, which can be written as, because there is a power up there which is 2 over 3. So this is a to the power of 1 over 3, that means 2 to the power of 1 over 3 is equals to a to the power of n. Now clearly, if they have mentioned a as an integer, this is the first value, and if a is integer, I can say a is 2. In that case, n will be 1 by 3. If a is an integer, then n will be 1 by 3. There is another way, which if I do not simplify it, I can write root 2 to the power of 2 over 3. So a is root 2 and n will be 2 over 3. That's the two ways of writing it. There is no other third way. So because they have specifically mentioned that a is an integer, so in that case, I'll be selecting this way. That means my a is 2 and n is 1 over 3. If a is 2 and n is equals to 1 over 3, then 2 root 2p plus 1 over 3 is equals to 4. Bringing 1 over 3 onto the right hand side, 4 minus 1 over 3, which will give you 11 over 3 is equals to 2 root 2p. So p will be 11 over 3 times 2 root 2, which is 11 over 6 root 2, and then rationalizing it, root 2 over root 2 will give me 11 root 2 over 12. And that's your final answer. In the following equation, n is an integer greater than 1. Root 5 whole to the power of n by 2 is equals to m root 5. Find the value of m if n is equals to 6. Simple, you just need to substitute the value, sub in the value of n as 6. So root 5 whole to the power of 6 over 2 is equals to m root 5. Or root 5 to the power of 3 is equals to m root 5. Now, root 5 to the power of 3, that means root 5 times root 5 times root 5 is equals to m root 5. Dividing both the sides by root 5, I'll get 5 is equals to m, because these two root 5s will give me single 5, and then I can divide both the sides by root 5. In that case, I'll be getting m is equals to 5. Then find n if m is equals to root 5. So find n. That means root 5 whole to the power of n over 2, and m is root 5. So root 5 times root 5 is 5. But whenever we are trying to find, just keep that in mind if you are finding any power. So your base number should be same. So if I multiply root 5 and root 5, it will give me 5. And that will not make our base number same. So in that case, root 5 times root 5 can be written as root 5 whole squared. It means the same. So root 5 is equals to n over 2 is equals to root 5 whole squared. In this way, I'll be able to make the root same. I mean the base number same. Since root 5 are same, I can compare the powers and n will be 4. Moving on to the question number 7. In the rectangle given above, the length AB is 30. This is 30. So obviously this will be 30. And the width is 20. So this will also be 20 since it's a rectangle. Then find the length of the diagonal and give your answer in a surd form. So diagonal, that means they are asking this one. This is called diagonal. And this we can easily calculate because we know that a rectangle has all the angles 90 degrees. So when I divide it, this diagonal, obviously this is a right triangle. And I can apply Pythagoras theorem. So in the given figure, I can clearly see ACD is a right triangle because it's a rectangle and all the angles of rectangle is 90 degrees. So now applying Pythagoras theorem, I can say 20 squared plus 30 squared is equals to 80 squared, and this will be 400 plus 900 is equals to 80 squared. This is 1300 is equals to 80 squared. 80 will be taking root of 1300, which is 10 root 13. So 80 is 10 root 13. Obviously, when I'll take the root of 80, I'll get plus minus 10 root 13, but a length can never be negative, so we are just opting for the positive answer. Now part B. Area of the square given above is 300 centimeters squared. If E and F are the midpoints of AC and CD respectively, then find the length of EF, given your answer in the form of A root 6. Now, since the area of this square is already given, which is 300 centimeters squared, it will help me in finding the side of each side of this square, and which is if I root it, because the sides are, if I say the length is A and width is A, so obviously length times width A squared, side by side times side will give you the area of this square, and which is equals to 300. So A will be equals to 10 root 3. So this is the side of each. They have mentioned E and F are the midpoint. E is the midpoint, F is the midpoint. That means clearly EC, this part, will be 10 root 3 divided by 2 because it's a midpoint, which is 5 root 3. Obviously, it will be half of it. If E is the midpoint, then EC will be the half of AC, which is 5 root 3. And similarly, I can say CF will be 5 root 3 as well. And now you have to calculate the length of this EF, which is basically the diagonal of this right angle triangle, because we know that all the angles of a square is 90. So in ECF is basically is a right triangle. So we are applying Pythagoras. 5 root 3 whole squared plus 5 root 3 whole squared is equals to EF squared. So EF will be 2 times 5 root 3 whole squared, taking root, we can say if you root the square, the answer will be the same number. So 5 root 3 whole squared, and rooting it will give you 5 root 3. And when you root 2, it will give you root 2. That means answer is 5 root 6. And that's the length of EF. And it has to be in a form of A root 6. So yeah, it is. Now simplifying the following expression, this is actually whole root. This is 3 6 root. That means if you write this is a mixed number, question is 3 6 over 25 plus 2 over root 5. On simplifying, 25 times 3 is 75 plus 6 is 81. Root it plus 2 over root 5. Root of 81 is 9. Root of 25 is 5 plus 2 root 5. Now, this is the actual form in which we have to convert, and clearly you can see it has a denominator, an integer denominator. So in that case, I'll have to rationalize. You can rationalize separately, obviously, nothing wrong. So root 5 over root 5, 9 over 5 plus 2 root 5 over 5, which can be written as 9 plus 2 root 5 over 5, which definitely looks like this. So this is the format that they were asking for. Now, given that 5 root p plus 4 equals 0 and p is equals to 2 to the power of n, then find the value of n. Either you can put that value right away, but I think it would be better if we'll solve p first. I don't know, but definitely it's looking like a quadratic if I'll assume p as x squared, or we can say root p as x. If you assume root p as x, then squaring both the side, x squared will be p. I need to replace, because root p we have assumed as x, so this will be 5x plus, then p will become x squared plus 4 equals 0. Now it's definitely looking like a quadratic, which is, yeah, it is. So x squared plus 5x plus 4 can be factorized at x plus 1 and x plus 4 times x plus 4 equals 0. That means x1 is -1 and x2 is -4. But we have assumed x to be root p, which means root p is equals to -1 and root p is equals to -4. But we have given the value of p as 2 to the power of 9n. So here I have to square it. When I'll square it, p is equals to 1 and I can say p1 equals 1 and p2 is equals to 16. Then I can replace value of p. So p is given as 2 to the power of n, which is 1, and 2 to the power n as 16. So 1 can be written as 2 to the power of 0 and n is 0. And 16 can be written as 2 to the power of 4. So n is 4. So there are two values of n we got, one as 0 and one as 4. I hope it's clear, and if I was a little faster and you were not able to process it, you can just go back and see the video once again. Now, question 10, which is the last question, because this is the 10th question to ace your topic. The last one says 5 times, let me just rewrite this, it's 5 times complete x over root 3 plus 5 over root 3 is equals to x minus 1 over root 12 plus 2 over root 27. I can clearly see I have to simplify this one. So this can be written as 5x plus 5 over root 3, clearly because root 3s are common. Then I can clearly see that because root 3 is somewhere on left hand side and on right hand side we have those sort of numbers that can be simplified. So just go and simplify them. So x minus 1 and root 12 can be written as, on simplification, 2 root 3. And 27 is 3 root 3 because 27 is 3 times 3 times 3. That means this is 3 root 3. So I can, if I multiply both the sides by root 3, 1 over root 3 or 1 over root 3, I'm sorry, 1 over root 3 is already given, and if I multiply both the sides by root 3, I'll get 5 times x plus 5 is equals to x minus 1 over 2 plus 2 over 3. Now expanding the bracket, I'll get 5x plus 25 equals x minus 1 over 2 plus 2 over 3. Now bringing all the numbers on one side, let me say 5x, and I can split x minus half as x over 2 and minus 1 over 2. So 5x plus 25 is equals to x by 2 times minus half plus 2 over 3. Now bringing all the numbers and x's on one side. So all x's on one side will be 5x, and I need to move x by 2 onto the left hand side, so sign will change. Similarly, bring 25 onto the right hand side. So this will give me 2 over 3 minus half minus 25. So this will be on simplifying because we have to make the denominator same. So I'll divide and multiply it with 2 clearly. So this will become 10x minus x over 2, which is 9x by 2. And this is 2 over 3 minus half. I have to take the LCM, which is 6. So when I take LCM as 6, this will give me 6 minus 3 minus 25 times 6, which is 150. 9x over 2 is equals to minus 147 over 6. Then for x, now let's see, this is given 9x by 2 is equals to minus 147 by 6. Multiplying both the sides by 2, I'll get 9x is equals to minus 147 over 3 and dividing both the side by 9, x is equals to 147 over 27. So this is your final value for x. So basically that's it for today, and in the next class I'll be back with the new topics. So keep on revising, and also if you need help for physics, I am uploading questions there, so just go and gain your knowledge. So that's it for today. Bye everyone, take care.